Well, we're back, and this is Unit 2.4 and 2.5. So what we're going to be doing now is we're going to be calling methods. Okay, we're going to be calling some a void method with parameters, and we're going to be calling a non-void method as well. We did this before. We did a non-void method at the top, right? We did this in 2.3. We were calling, for example, get y. That returned something. It was not void. No parameters. And so we're going to be looking at calling methods. And what we're going to do that is just instantiate objects from quadratic solver. We created that in the last session. So what we're going to do is make some instances of that class and make some calls. That's all. So to make an instance of the class quadratic, we've got to use the constructor. So I'm going to do that. The first one I'm going to do is I'm going to make a quadratic solver instance object, and I'm going to call it solver, and it's equal to new quadratic solver. Now if you remember, this one was creating a quadratic solver where the A, B, and C were all 0. I'll remind you. Let's click over here. Let's look at the constructor. This one. This quadratic solver right here is the one that's coming after the word new. I'm going to go back. So all A, B, and C are zeros. So you can see here that I'm creating, that's the constructor here, I'm creating a new instance of the quadratic solver, and the name of my object is solver. So I'm going to make a non-static call here. So the first thing I'm going to do is I'm going to say solver dot print. Now you realize if I hit the dot, the code completion comes up, and I'm going to call the void method here print solution, and I'm going to save it and I'm going to run it just to see what happens. Okay, obviously we get all the stuff from before, but we got two nans. Okay, we got not a number, not a number. So all zeros in the quadratic solver. So we used this guy, and we got a NAND. So let's see. Let's run this again. Not a number. Not a number. Let's go ahead now and take the quadratic solver and try to find its discriminant. Solver dot discriminant. So you realize I did not actually put this inside of a print because it is a print and there was nothing being returned. If I put this inside of a print, it would not work because there's nothing returned to be printed. So now we're going to try the discriminant. Let's run that again. And we got zeros. So the question then is, why did we get this NAND for my two answers? Because we have this print solution and we got two NANDs. So I wanted to think about that. We got two NANDs, mean not a number. I wanted you to see that. Not a number. So it's not so good to have these zeros. So where did that zero come from? Well, let's check back at the quadratic solver. The discriminant is 0. That makes sense because 0 squared is 0 and minus 4 times 0 times 0. This whole thing will be 0. The problem comes in when we went to print the solution, and we call this one. This print solution called solve. And solve is this, but A is 0, right? So we are literally doing a divide by 0. So because this got me not a number, it turned into the string version of not a number. and so I printed not a number. That's okay. We expected a mistake if the quadratic was not a good one. That's all right. Nothing is wrong there. So now let's try doing another print. I'm going to use the same quadratic solver. I'm going to say, hey, solver, why don't you solve? Now I'm looking for the one that has a return. So solve for me 1, -2, 1. Now one thing we got to be careful here is that this print solution here that I have here actually prints. So I can't put it inside of a print statement because there's nothing being returned here. This simply prints the answer. So I can't print the print. That doesn't make sense. So what I'm going to do then is if I get rid of this print, now you must remember the A, B, and C's up here was 0. But once I gave the A, B, and C in this print, let me remind you, that's the print parameters. It then asks to solve with the A, B, and C, and the A, B, and C calls this method who sets up the A, B, and C. So let's go back and run that. And yes, our answers are 1, 1. Now I don't know if you recognize, but I just did what is called a perfect square trinomial. This was actually x squared minus 2x plus 1 equals 0. If I'm solving this, it factors to x minus 1, x minus 1, and so the two answers are 1s, 1, 1. And remember, they were doubles, so 1.0, 1.0. And you should be saying to yourself, how come you put nths in here if these are supposed to be doubles? Widening conversion, widening conversion. So even though I put 1, -2, and 1, what actually goes in is 1.0, -2.0, and 1.0, because they are doubles. I'm going to make another one. I'm going to make a quadratic solver, another one, but this time I'm going to call it quadratic solver 2. And instead of it being zeros, I'm going to say, all right, here are my, use the same example again. It's another way to make it. Now I've created this. So what if I said to quadratic solver 2 to print your solution? Okay? So quadratic solver 2, print your solution. And run that again. And here we have it. See, quadratic solver 2 printed the same solution that I got here from the first quadratic solver. The issue up here was we didn't give it A, B, and C. We put them all 0 and we ran into a NaN. But now that we created it using the other constructor, overloaded constructors, default, non-default, I could just simply print the solution. So you could look at this and say, oh, this is much quicker. Yeah, but I gave flexibility. You could do this. Don't print quite yet. Give it the values and then ask it to print it. So there's a lot of ways to do the same thing. I'm giving you, it's very similar to saying like Command S for save or File save. Different ways to do it. Flexibility in your code. Okay, so now that we've done that, let me go ahead and try checking out how my discriminant would look. Okay. So I could say, hey, quadratic solver 2, what's your discriminant? And let's see what that gives me. It says its discriminant is 0, which makes sense. Okay. B squared minus 4AC is 0. Okay. 4 squared minus 4. I shouldn't say 4 squared, sorry. 2 squared, which gives me 4, minus 4 is 0. Because B squared minus 4AC. So now that we seen how to instantiate objects, specific instances of the class. This was the instance with A, B, and C being 0. This is the instance with A being 1, B being -2, and C being 1. These are integers, but because of widening conversions from 4 bytes to 8 bytes, it's okay. The system turn these into these for us. And then when we ask it to print the solution, we realize the print solution has some way of setting up those variables. using those variables to print. The discriminant happens to be 0, and we saw all of that. So this is 2.4 to 2.5, just basically making objects, calling methods. This is how you go about creating an app. Okay, you make many instances of all different objects, and they all work together in some way to create a nice smooth app. And that brings us to the end of 2.4.